Alright, another drag video. Yeah. So this is complicated. Lots of push-pulls and, you know, follow the bouncing ball, how you want to put it. Lots of distractions and things you can miss. And so, even though I like components of what I've presented, it's still not quite right. So, I figure we'll just illustrate the basic problem. And just again point out that conventional physics has no explanation for maintained velocity. They don't really explain why the particles of an atom don't really behave like the whole atoms do, in the sense that you can push whole atoms through space and they keep going, but the little particles don't seem to have any such will to do that. And so there is something in the mechanism that even in their theory, where they've taken the energy of gravity and made it in another dimension, so they don't have to account for its creation at all. They just say the geometry makes it happen. Things just move. They're the ones with the magical explanation, in the sense that it's a perfectly reasonable explanation to say it's magical, because they basically just produce the pigeon and say, voila, I produced a pigeon. And we're not given any explanation for what made the pigeon. So they're putting all other theories at a huge disadvantage, just in the sense that ones that have to work in the real world and can't just pull pigeons out of sleeves, they're kind of stuck, because the real world is there's a catch and you got to find it. You have to find the real catch. You can't just find fake ones if you're looking for a real answer. Now, if you just come up with another magical explanation, you could just say, like I could just say with any one of the components in my previous explanations, I could just say any one of these components acts in a magical way. It doesn't do what it usually does. And so therefore, I can just make this work, because I can just give something a supernatural capacity, like bent space gives material objects, or magnets give atoms. The creation of virtual photons. So I just want to emphasize that all these people who, it's just a hypocrisy and a duplicity to sit there and have these two standards, where it's okay for your theory to invent magical dimensions and have magical functions, but any opposing theory is not allowed to bend those corners. And that's just unfair. I mean, not to at least acknowledge that if somebody does come up with a theory that doesn't produce pigeons, that you'd have to automatically say that's got to have an edge over your theories. So anyway, it's just well, whatever. Life is unfair, and people suck. So what are you going to do? All right. So the problem is in any theory where you actually have the energy in the universe to create gravity, you're likely going to run into this problem of velocity drag, which is essentially, it's like the ether argument even too, in a sense, where you have force that is in the system, and that it's that force that somehow has to be traveled through. So the point would be is there's more force coming in one direction when you're moving in a direction. You're encountering more. Alright, I don't know, this doesn't, it looks pretty obviously more on top than on bottom. So if you're heading in this direction, you're encountering more force in the direction you're heading and less in the direction you're not heading. So even if it's an ether, jello, you're going to smash into more jello in one direction than the other. And if it's an active jello, well, the same rules apply essentially, because the activity is going to be at the speed of light. So all ether theories have to overcome this, and lots of people have ether theories and they really don't explain how they overcome it. So at least I'm being honest enough to say, yes, it's a real problem and you have to have a solution for it. Now, I'll just say there seems to be a double standard, because there's all of these people with ether theories, the electric universe people, all these people, Ken Wheeler, all these people, and none of them are explaining how they've gotten over this problem that they're going to crash into more ether in one direction than in the other. you know, but whatever. They're going to have to plow through more. I mean, it either has properties or it doesn't. You know, it's okay. They can make it magical, and that the ether only has a reality when it's doing specific things, and it doesn't have any reality when it's not doing them. You know, but those are pigeons that pull out of a sleeve. So anyway, so it's coming up with some solution that basically, what you have to come up with is a sail, like on a sailboat, that works in an interesting way where it somehow catches more energy going this way, and it somehow just, you know, without any force, it gets rid of the energy it's plowing into. So it either gets rid of energy, like it doesn't, makes it more invisible, or it has to make this energy more visible. But that's about the only way you can fix this, I think, you know, if I'm going to be honest about it. So I've attempted to do that with different arrangements, and they have elements of, you know, and you're saying you're getting closer, and I probably shouldn't make videos until I've thought about some of these ideas for a day or two, and you know, I had time to think, oh, I forgot to think about how that works, and oops, I forgot that. And you know, so that's my bad. But you know, this is a one-man show, and you know, I don't have the capacity to just, you know, put things, you know, on different shelves and play all, you know, those kind of games. I just, you know, I'm working on it. It's in process, so I make the videos. You don't have to watch them. I mean, you know, obviously I'd like you to watch them and like you to believe that they're going to be worth your time. And I don't think the conversations in the videos are probably worth your time. But regardless, I'm apologizing to those who just find, hey, you wasted some of my time with an idea that doesn't work. Okay, I'm sorry about that. So anyway, so a thing that I have always thought about is the size difference between electrons and protons. So I'll keep the colors consistent. Protons are, so let's just understand that physics has numbers for this, but they can't really see any of this stuff, and there's no way to measure because you can't really put them on scales and weigh them, even gravitationally, because the charge just makes it impossible. Anything they get near the charge is going to influence the weight, and it's going to be very difficult. But there's a general impression that protons are much bigger, yet they have the same charge value. So even though they're much bigger, more massive, they only produce the same amount of charge as the electron produces in the two proportions. And that's always been sort of a thing that bothered me, in the sense that, well, that's worthy of an explanation. You know, that should be explained. And so I have thought in the past that the two forces may not be, you know, I've always just said, because it's easy to say, well, there's 50% red force and there's 50% black force. There, problem solved. And it makes it easy for thinking intuitively, because you say, well, that makes sense because then magnets are balanced and all this other stuff. But the truth is, I don't think there's a real obstacle to saying that there could be 10 times more red force than black force. There's no law against it. And most of the things in the universe will still work because the forces, as stated before, don't interact. They only interact with the matter of the specific polarization that's relevant to them. So it may make no difference at all in terms of changing the proportion. But what it would make a difference in is in this scenario. Because in this scenario, if there's twice as much black force, so another reason why I was thinking the forces are not even is I was thinking these two objects are really the same object. It's just there's more pressure on the electron, so that's why the electron is smaller, is because there's much more force pushing it together, holding it together. And I've always speculated that inside is force trying to get out, and it doesn't get out because it's constantly pushed in. And that's the nature of material objects. They're really just force being caged by the external energy. So in that scenario, it would make sense that the big thing, the bits are allowed to travel further before they hit something that pushes them back in. And this is all by probability. So obviously this is a million transactions blended. So their shape at any one time might be incredibly eccentric, but their shape over time would be spherical if the force was even. So this is being affected by a much less force gets to the proton. So that's another reason, a way of understanding why this difference has other indicators that it might exist, that the two forces might have a different density. Alright, so now let's say they did have a different density, and we have something called a neutron, which is a proton and an electron. Now you could sort of understand that if there was a force coming from this direction, alright, we'll try to make this as proportional as possible drawing. So let's just make 4 of each. Well, that was exactly what I didn't want to do. Yeah, I only make 2 reds and 4 blacks. Well, you can see that both the reds will hit a red, so that's a that's a 1, we would say. So we'll just mark it as a 1 because that's a 1 interaction. And there's 4 blacks, and the 4 blacks though are just half interactions because the blacks are going to end up leaving perpendicular. So the rule is the thing of the opposite color goes in and leaves at a 90-degree angle. The thing that's red is a perfect reflection, it goes back. So these interactions create a 180-degree change in direction. These only create a 90-degree change. So you can just think of it in that terms, is that these the head-on collisions are a full reflection, and the red, the black on red would only be a 1/2 interaction, and that's sort of the difference. So anyway, so in this scenario, the blacks just all go through because they can't get to this guy, and the reds, they're full interactions. So it only has 2 full interactions, and whatever, 1, 2, 3, 4 halves. So 4 halves would be 2, and plus 2 is 4, let's say. Alright, now you say that you have the opposite scenario, and you have to understand now there's more energy, more black energy. So let's just do it with the same numbers, and then we can see that in the same circumstance it's going to be there'll be an asymmetry. So we have 4 blacks. Now the trick is all 4 of them won't hit the little black thing, but let's say 2 do, and 2 reds, which may hit one or the other, so we'll just go 50-50 there. So now you have a full interaction. Let's say you have 2 full interactions here, against the electron. So you got 2 fulls. You got 1, 2, 3, 4, 5 half. You got 5 half. You got 1, 2 halves. So that's plus 1. And then you got these 2 that are going to hit the red, or one of them might hit the black. But let's just say they both hit the red to give them fulls. And that's going to give you, well, let's say, well, no, to be fair, half plus a full, so it's plus 1.5. Alright. And that all sounds a little bit complicated, but it ends up being 4.5. Now, it could have been 5 if I made that a 2. But that's, you can get the idea that the force that's more dense, you can get the idea if I would have said it that way, which I should have done. Alright, the point is you have a more dense amount of blacks than you have reds. So the dense force, see, everything would be equal if this wasn't here, the little electron. So that's all I'm saying, is you can sort of understand that everything would be equal if you just have the red thing, in the sense that what interactions there are is going to be the same, except for the more that's coming down from one end. But if I put the electron on this side, it's going to receive more of the full interactions with the denser force, and it's received no interactions with the denser force coming from the stream that has more force in it. So the direction you're going in has no access to the denser force. The direction you're not going in has full access to the denser force. So that's pretty much the simplest way I can put it. So I should just write that as a sentence, and so I'll just remember to do that. So it's really about how much access you have to the denser force. So even though you have more force hitting you from the direction you're moving in, you have more access to the denser force in the direction you're not going in if the electron is behind the proton. Now, another reason to think this might be a viable explanation is that nuclear bombs, I mean, let's just show it something like that, depend on neutrons to create the chain reaction. Because the consequence of this, if the neutron isn't spinning, it's going. So what could be argued is that you have the neutron, and I mean, you know, the neutron is essentially a proton and an electron very close together. Now, if this neutron isn't spinning, I mean, it can spin here, or the electron can spin. It doesn't matter where you think the spin comes from. The whole object spins, or just the electron spins. But regardless, if there is no spin, then this object always would move in the direction, you know, of this polarity. Of its, you know, it's a polarity. So we're back to magnetism, of course. And so it has to have rotation. So it has access to all directions. So it's essentially moving in all directions, but it's spinning. So, you know, spinning and moving. So it's just processing in a spot. Now, you could argue that if in things like helium atoms, which I might as well draw since I'm doing this, helium nuclei, you could argue that the only electrons are the ones associated with the neutrons. And sorry, those aren't very visible, so I'll make them more visible. And that they aren't spinning when they're locked in the nucleus of the helium. And so the helium atom would have a tendency to move in a direction, unless the helium nucleus, unless it was spinning. So the idea would be is that this rotation would be much slower than this rotation, and certainly when the neutron left the atom, that is when a neutron goes in and breaks these nucleuses up, that's what's happening in the chain reaction of a nuclear bomb. And what's happening is that these neutrons fly out when you break it. So one goes in, essentially 3 can fly out because your original one might still be intact. And then especially when these are really heavy uranium atoms, there's a whole bunch of neutrons in there, and you're releasing all of those neutrons. And the point is the neutrons would leave with not only the energy of the fact that the nucleus was broken, but they have their own velocity engine if they're not spinning. So you could argue that inside the atom their spin has been converted into a rotation of the entire nucleus, and that their individual momentum now is very high because they're just a momentum engine. You know, their unspun state is one where they have a directionality, a decided movement. So the point is that they would be more energetic than you would expect. Once you release them from an atom, their bond, they don't fly out with the same energy of the impact. They fly out with their own energy added to that. And that's why they're so good at creating a chain reaction that disintegrates the uranium into all of its very energetic, free neutrons. They even have a thing called a neutron bomb. I don't know exactly, but obviously my whole point is yes, neutrons probably are capable of being related to things that could be very energetic if you have neutrons that aren't spinning. So I would argue that the neutron is the thing that's really holding momentum inside of atomic nucleuses. So anyway, I'm just using that point just to say there's reasons to see that neutrons are energy possessors. That does create a symmetry with this idea of the force imbalance that creates the opportunity to make a sail that can see more energy coming from the bottom than from the top. So the argument essentially is the neutron, say if you have more energy coming from one side than the other, the imbalance of the neutron, in the sense that it receives more force, just draw it, from the bottom, because it has exposure to the denser force, the black force, than from the top, because it has all exposure to the weak force, not the strong force. So that's probably another way to say it that's not terrible. So I'll let that sit for a couple of days and try to refrain from making any further drag videos until there's reason to, until somebody makes some statement that points out how none of this is even possible. But anyway, I mean, the fact that there's the fact that no one's going to uncover, no one's going to dig up obvious gold anymore, if you know what I mean. It's not like you're not going to find answers that have just been sitting on the surface right in front of our face. Well, frankly, some of them are. I think they are pretty glaring. And the clear thing too is the point isn't so much how. The point is the answers they have accepted are so phantasmagorical. I mean, they're so, again, it's the UFO argument. If you're going to claim something extraordinary, you should have at least ordinary evidence. And the argument is they're claiming extraordinary. Time is a dimension, dark matter, geometry makes things move, virtual photons that create themselves and annihilate themselves. Stuff that their whole structure is dependent on a ton of these magical functions that are essentially extraordinary claims, and they don't have even ordinary evidence, let alone something called really good extraordinary evidence to defend the existence of their magic pigeons, that are just really being pulled out of a mathematical sleeve. It's a gimmick. It's not a reality. So anyway, that's the real key argument. Isn't so much that yes, science is hard. The scientists should know that, and they're cheating the science by their enthusiasm. And I understand getting caught up in it, because I've gotten caught up in it. I've thought I've had good ideas, and if everybody just clapped and said, "Bravo, Gary, great job," then I might have stopped thinking, And so, yeah, maybe physics did that. Everybody got into a group and say, "Well, that's better than anybody else's dopey explanation," and that's sort of what happened with Einstein. There was no theory of gravity. The greatest man in the history of science, Newton, said, "I don't know. I don't got a clue how it works. I'll tell you what it does, but I don't know how it does it." And nobody since Newton had the balls, so to speak, to stand up and say, bleh. And if they did, they got shot down, because it's difficult. It's going to be the answer is going to be subtle and complicated, in the sense that it's going to be subtle, and that's going to make it complicated, because it's dependent on these little subtle nuances that exist in the universe. And to get it all right, you kind of have to get it all right. You can't make too many mistakes, or all of a sudden the whole thing starts crumbling. Anyway, I'm just editorializing a little bit on what this conversation is about, in the sense that 300 years ago, human beings came to the realization that you could sort of explain why things shadow each other, and that it would mock gravity. It would explain gravity if you had an external force that was affecting things. And instead of saying, well, that's a kernel of an idea, and let's carry that around with us because that concept fits an awful lot, because it didn't have the subtlety of being able to explain these little problems, in my opinion, of dealing with a little bit of heat and a little bit of drag. They just threw it out. And then they, in contrast to the fact that Einstein suggests a completely different dimension, completely magical properties, and nothing is hard evidence of anything, and everybody jumps on that bandwagon. So I'm just saying there was two wagons here, and it just seems their standard for what they'll jump on doesn't seem to have any rational coherency, because there was nothing on that Einstein wagon that was in any way better rationally. It's just different, and the difference is one solution is prettier because it uses magical ways of producing the show, and the other guy's show has to be done naked. He doesn't have any sleeves to hide the pigeons in. So you're comparing two magicians, one with a full tuxedo with lots of pockets, and the other guy's out there in a Speedo, and he can't just pull pigeons out of his sleeve. He can't do little tricks. So that's a good way of analogizing it. And you guys, in watching the competition, you guys just said, okay, the guy who could do the magic tricks is just so much better a magician. When that's not the contest. You got to give the guy who comes up with anything at all when he has no sleeves some kind of credit if he puts on any kind of show at all, because he has to do it with facts. You can't do it with tricks. And so bent space is a trick, not a fact, and you went for it. Okay, well, that's the reality. I'm going to try to explain why you've been unfair to the thought process, and you've cheated yourself out of the truth. Yeah, that's what I'm doing here. Alright, so that's enough. So I will attempt not to make another video in this series for at least 2 days, or some kind of prohibition like that. But this is I think this is the point. Again, just think of it in this way. You have to have a sail that somehow receives more energy from one side than the other. And something like this, something polarized, can do that. It has consequences in the rest of the universe, again, but I don't think there's any that I can't that can't be explained to be not to critically screw up things like magnetism and other mechanisms. So I think this is safe in terms of what it messes up. Alright, enough of the video. Till next time. Such. So I gotta do a comment video. But yeah, I'm not gonna add comments on these videos anymore. So comments are just never enough on subject. So, but whatever. Till next time.